hello, everybody. How is everybody doing today? I hope everybody is doing fantastic. Hopefully we're doing really good today. Alright. Good to see everybody today for a second go around of Math 102. Right. Not going crazy. Alrighty, that's fine. Hey Bill, how we doing? You have been problems getting into my math lab. What seems to be the issue, my friend? To say you're having issues with my math lab, I mean, that's fair. I mean, if I can help you, then let me know how I can assist you there. Hey, Focus, how we doing today? Thank you so much. I'm doing very well this Tuesday afternoon / night. So probably turn night by the end of the semester for sure, but yeah, doing well tonight. Doing well tonight. Well, if you could tell me what the issue is, then I can help you out with whatever you need help with. So you bought the book in the lab, register for $80. Did you use the course ID as well, Bill? I need to ask you that if you use the course ID with that. Yes? Okay. Let me check to see what you registered under. Maybe you're using a different account. I don't know. Maybe you're trying to log in with an account that's another. I don't know. Let's find out. I'm gonna send it to you in a whisper there. So, while we're waiting for people to come on in. Hey, Eugene is here. Hello, Eugene. How we doing? Okay. All right. All right, Bill. I'm gonna send you a whisper here. That's that little message box in the upper right-hand corner of your screen there. Um, that's the email address that is on record that you signed up with. So if you have that already set as your email, the one that I sent you here via a whisper, then uh, that's the email that I have on the account. As for the password and stuff, yeah, so I have you already enrolled in my class. So you should be able to enroll. You're already enrolled in the class. I see you right here on my list, like as an active student as part of the course. So you should be good. You should be good to go there. Should be good to go there, Bill. At least from where I'm sitting anyway. That's what I see. Now, what we could do is we could talk a little bit. Okay, so I'll need to take a look here at what you're looking at. All right. We could talk after class on Discord, and then I can see what you're seeing on your screen, and then we can see what we can do together. Okay. Let's talk a little bit after class, and then we'll talk on Discord and see what's going on. Okay. Because then I can view your screen and be like, okay, what's going on and stuff. So let's figure it out. All right. All right. Very good. Very good. Okay. Excelente. All right. Okay, let's go ahead and do this here, ladies and gentlemen. Let's go ahead and do some intros for time here. That's fine. All right, so let's do a few intros, and we'll get started here with the new material. All right, ladies and gentlemen, let's go. All right, let me turn that down by a smidge. Perfecto. All right, let's do this. Okay, let's get started today. Welcome back to Tuesday. Hopefully, you have a nice weekend. All right, so for today, ladies and gentlemen, we're going to pick up where we left off last time. Last time, we finished off half of Chapter 1 here, and what we're planning to do here today is to finish off the rest of the definitions here within Chapter 1, and then move on here to Chapter 2. We're going to hopefully get a little bit of Chapter 2 in as well. We can get the ball rolling on that as needed. Okay, so let's go ahead and do that right now, and we're going to see what we're working with, all right? Okay. All right, so there we are. So it's a big board here. Let's go to the big board. There we are. Okay, so let's talk about where we left off last time. Last time, ladies and gentlemen, we left off at the very end of section 1.3, which talked about simple random sampling. All right. So this is going to be important here for what we did here last time. Now, if you remember here, simple random sampling as a definition from last week, we said this is a sample in which every member has an equal chance of being selected. Meaning to say, if we took a survey, the person, say, clear across campus, has an equal likelihood or chance of being selected as being part of our survey as much as the person that's sitting right in front of us. That is truly randomized in nature and is a simple random sample pretty much straight up. Now, there is a problem with this definition, and the problem with the definition is that maybe you don't want to go clear across campus to go pick a person that's equally likely to be selected for the survey. Maybe you want another system in place in order to pick the sample here appropriately and still try to remain as randomized as possible. All right, so this is especially useful here in more face-to-face surveys, as opposed to other things, but still an effective method to try and remain as randomized as humanly possible. So let's talk about how we can sample in several different ways. Let's look at the very first question here from the second half of from the handout here from 141516. All right, so let's look at question 1 here. It says, what is a stratified sample? So a stratified sample here is a random sample that you choose based on an attribute or characteristic. So for example here, a good example of a stratified sample is, let's say I wanted to take a survey. Let's say I wanted 100 people to take that survey. But maybe I classify people, again, based on, let's say, gender. So I say, all right, male and female. And maybe I have, I want 50 men and 50 women. And I could pick 50 men at random. I could pick 50 women at random. But that's the way I'm going to set it up. I'm going to first categorize and then randomly choose, the requisite 50 men and requisite 50 women to take part of my survey, like saying, hey, you like brand A or brand B. So that is going to be a stratified sample. Pretty much straightforward, pretty straight up. Okay, very good. All right, let's look at the next example here. Why do you do that? I don't. All right, there we go. Okay. Next, the next type of sampling here is systematic sampling. So let's describe what systematic sampling is. Systematic sampling is a random sample in which you choose every kth individual starting from anywhere you want until you have your desired sample size. All right, so what exactly does that mean here? All right, meaning to say, let's say you have a line of people. And again, let's go back to our example here where we say, hey, I want 100 people to be part of my survey. Now, you can make a little system in place. Starting from anywhere you want, you're going to pick in this case, let's say every fifth person to be part of your survey. All right. And so let's say, again, the example that I have here is that let's say you choose to pick every fifth person in line, and let's say you randomly start at the fourth person. Again, truly random on where you start. You do not have to necessarily start at the very first person in line. You can start anywhere you want. So I could start at the fourth person in line to be part of my survey. Then I pick 5 people after that. So I pick the fourth person. 5 people after that would be the ninth person in line. And then from pick 5 people after that, it would be the 9th to the 14th person in line. Pick 5 people after that, that'd be the 19th person in line. 5 people after that, be the 24th person in line, and so on and so forth until you get 100 people to be partaking in your survey, and you have your uh, required sample size or whatever sample size you want at the end of the day. So that is a systematic sample. All right. Next, let's talk about cluster sampling. How does cluster sampling work? Cluster sampling is that you randomly select all individuals within a collection or group of individuals. Okay, so the way cluster sampling works is that you basically classify everyone in a particular, let's say, area, group, whatever. You classify them based on a characteristic or attribute, and then you select a chunk of them or a cluster of them to include as part of your survey. So the best example that I could come up with is that, let's say if we were in the classroom, I could say maybe there's rows of desks, maybe the first row, second row, third row, and the back row of desks. And I say, okay, I want you to be part of my survey, and the way I would pick who the people are, or you would be, that would be, let's say I pick the back row of people randomly to say, hey, you guys are going to be a part of my survey. Okay, again, it's random by choice, but I first arrange the people into, say, rows, or again, I could arrange them into columns. I could arrange them into gender before I pick them in clusters. I could arrange them into age groups. I could say, okay, I pick only the people who are between the ages of 18 and 34. They're going to be the people that are going to be part of my survey. So I group those people up and I take them as a big cluster, and I say, you're part of my survey. Fine. So that's the cluster sampling here. You have to do a little bit of work beforehand until you select that group or cluster of people. But that's essentially how that goes. All right. All right. Next, are there actually before that? Are there any questions? Any questions at all before I continue to move forward? Any questions? No. So the difference between Horitz, the uh, the difference the difference between cluster and stratified is just basically basically separating out your sample based on some attribute or characteristic. Cluster takes it to a second level. So you could say, all right, let's say I stratified those people. I based them on, say, male and female. And maybe I take a clump of the females and I take a clump of the males and I say, you're part of my sample. Okay, so essentially for cluster, it's like doing a two-step process here, where stratify is like, okay, I have men and women, and then those are the people that are going to be part of my survey because that's how I basically randomly selected it. Okay, so that's essentially the difference here. It's not a huge difference, but again, with cluster, you're just taking a group of people after you've already stratified the sample in some way, shape, or form. Again, The key thing being cluster or group. You're taking like a big chunk of people all at the same time. All right? All right, cool. Okay. All right, let's take a good look here at number 4. Number 4 is, what is sample of convenience? So, sample of convenience here is a pretty straightforward one. Again, we're going to look at the word convenience. This is a sample when we acquired in which individuals are easily obtained and not based on randomness. So the example that I have here is a grocery store survey at the front of the store. So let's say I have a stack of these surveys and I say, let's say I'm at a Jewel and I say, hey, here's a survey. I want you to please complete this survey. Tell me how we're doing here. How's our service here at Jewel or a grocery store? Tell us how we're doing and what we could do to improve it. So the thing is that if you're sitting in front of a store and you want to find out how that store is doing, you know what you're not going to do at that grocery store, as an example here? You're not going to go run all the way back to the milk section and hand a person a survey. The thing is that although it would be random in nature to run around the store and basically hand out surveys, the problem is that that happens to be very time consuming and very taxing. It's a lot more convenient for you to go ahead and say, when you see a person walk by the entrance, you hand them a survey and say, hey, can you take this survey and tell us how we're doing? So, in reality, you're not actually basing it on randomness. You're just basing it on laziness and convenience because you're like, I need to get these surveys out. So you're not being like, okay, you're there, here you go. Great. All right. So the randomness gets lost as a result of that because you're not considering any of the people who are actually in the store all the way in the back. Now it's just whoever's in front of you, they're going to get a survey, and that's how it's going to be. So that is a sample of convenience. All right. All right, so let's take a good look here at number 5. Now, we have one more type of sampling here before we move forward. Now, the last type of sampling here that we're going to look at is voluntary response sampling. So this is a sample that's required via asking a question, such as you ask an email or a phone call. So, for example here, talk show questions are very common voluntary response sampling questions. I mean to say, if you ever watch a talk show like Maury Povich or again Steve Wilkos or something like that, sometimes what they'll do in the middle of the show is that they'll post something. They'll do a little vignette and they're like, okay, what do you think about such and such's situation? Tell us your thoughts. Send us an email, give us a call, leave a message, and tell us what your opinion is about such and such. Did he or she do this, that, and the other thing? Okay, send us a call. Give us an email. So this is a pure voluntary response sampling. Now this type of sampling here is not the best. There is reasons why this is not the best, especially say a talk show situation. Again, the responses typically for a voluntary response are a little bit more extreme than that of innocuous questions. So you have to be really careful about how you ask the question. If you're not very careful about how you ask the question, you may get more extreme opinions than maybe because you're usually the people who email or call are people who are really like big fans of the show or something like that. So they always want to put their input in. So that's one of the issues about voluntary response sampling. We'll talk about that here in just a little bit. So that is what that is going to be. All right, so that's a voluntary response sampling. Okay. All right, so that's the type of sampling there. Are there any questions about that? Any questions about those two? Hopefully that's pretty straightforward. All right, let's take a good look here at number 6. Number 6 says, what is biased and unbiased? Okay, so that's the next two things we need to talk about here. In a statistical point of view, or even in an everyday point of view, bias is one of those things that is very important to talk about here and needs to be acknowledged. Okay, so we're going to talk about it from a mathematical slash statistical point of view, but in actuality, we actually want to be aware about other types of bias that can certainly happen, because let's not forget, in statistics, numbers can lie. You got to be pretty careful about that. And we want to remain as unbiased as possible based on the results that we're given here from the studies that we're doing here. So biased as a mathematical sort of perspective here is where this definition comes from, is where the results do not reflect or represent the population. So if you ask a group of people and they give you a different result than what everyone else is thinking, and those are reflective of biased results. Unbiased is just the opposite, that the results actually do reflect the population at large, and we actually have the proper reflection. Okay, so we have to be very careful about, again, we want to remain as unbiased as possible. Again, it is very difficult to remain unbiased because, of course, as bias in terms of a regular definition would be you have like a preference, or again you lean a certain direction. All right, now like I said probably earlier, it's like, hey, I don't, I'm not here to talk about politics, I'm not here to talk about the like, I'm just here to say, hey, you have a preference one way or the other, meaning to say you have a bias toward that particular thing or particular belief or that particular, let's say, food you like compared to other things. Okay, so bias is just inherent in everyone, right? But again, we try and keep as much bias out of our actual study as we humanly possibly can to get proper results. Now, let's talk about the sources of bias. All right, let's talk about the sources of bias, because there are certain things that certainly are applicable regarding sources of bias that we have to acknowledge. Let's take a look at the first type of bias here, which is non-response bias. This happens when not enough people participate in the study. So let's ask a simple question here for everybody who's in the chat right now. If I were to ask 10 people a particular, let's say, survey question, do you think 10 people's opinions could reflect an entire population of people? Let's say the population of a town was 100,000. Do you think 10 people's opinions would reflect 100,000 people? Think that's possible? Probably not, right? No, no. uh, all right. So the answer is definitely no, right? 10 people, yeah, they could tell you your opinion about, they could answer, do you like brand A or brand B, whatever the case may be. But that's not going to reflect what the 100,000 people are going to think about, say, the difference between brand A or brand B or whatever topic that you're talking about or surveying over. You know, that isn't going to happen. Okay, that just is never going to happen. So if not enough people respond, we can't make any conclusive results. So if anybody tells you, oh, what's the classic? Oh, this guy said everyone is, this guy, we get the class. Here's a classic statement you probably heard from people before. This guy says that everyone thinks in this particular direction about this particular topic. Well, the way I would kind of view that is like, okay, let's turn that argument around and ask them, well, how many people is everyone? Because I don't think everyone actually reflects everyone. And it says, well, me and my buddies, like you and your buddies are too small of a sample size to really to make a determination of what you're saying is actually true. That's too much of a biased argument. I'm going to need some more conclusive proof. Okay, so if there's enough conclusive proof, I'll certainly believe you. All right, let's talk about the next type of bias. The next type of bias here is response, or also called social acceptability bias. This is when the responses to a question do not reflect the true feelings of an individual. Let's go ahead and do an example of this. And this is probably one of my favorite questions to ask here in this course. So I'll put this as a 1-minute survey kind of question for you here. So this is the question I'll ask you, and you can answer yes or no. I have no stake in this game. Do you smoke weed? Yes or no? Now, again, I don't care if you smoke weed. I'm not here to judge you based on that. It's just a question. All right? So you could go ahead and answer however you like. I don't care. Okay? Trust me, I sincerely don't. So, what I care about, not here for weed. Dylan, you're all. Are you sure? um. So answer as you will. Again, if you answer honestly, it's up to you. Like I said, there's no judgment here. I don't care whether it's yes or no. I just want to see, whatever it is what it is. Okay. So it's like, hey, if you got stories for me at 3 o'clock in the morning because you're hungry as hell, and you gotta go to the gas station and get them, Cool Ranch Doritos, I'll be like, that's cool, man. I got no problem with that. All right. So 6 of you said no, 5 of you said yes. Okay. So that's perfectly fine. Now, let's talk here for just a moment. Okay. Let's talk here for just a moment. All right. So even though majority of you say yes, and 5 of you said yes, 6 of you said no, that doesn't really matter. But let's ask a question here, really quick, regarding marijuana or marijuana usage. Now, believe me when I say this. I'm going to switch to this screen here. Believe me when I say this. When we talk about marijuana usage, I'm all for the legalization of marijuana. I think criminalizing it just doesn't do anything. I think it's kind of pointless in my estimation. So if you go in and smoke weed, I got a good friend who smokes weed. I got no problem with him. He's a cool. So really, legitimately, like, trust me, I have no judgment with it whatsoever. It's pretty much the same as people drinking. So thing is, at the end of the day, let's talk about the perspective of where I'm asking this question. I'm not really asking this question in terms of as a teacher. At the end of the day, I'm just a guy. I'm just a regular guy. Okay, I'm asking this question: do you smoke weed? Yes or no? And again, there's no stake in it for me whatsoever. It's like, I just want to know if you do or you don't. Fair enough. Let's change the perspective here for just a moment, though. Let's say instead of just a regular dude, I happen to be a police officer. So let's say I was a police officer. Now, yes or no? If I asked you the same question, do you smoke weed? Would you tell the answer to me truthfully? Would you tell me truthfully that you would smoke weed? Yes or no? Okay. No, officer, I do not. I like that. A winky face, indeed. No, that's okay, Dylan. I hope they didn't come back, though, to your channel. No, I do crack. Gosh. Officer, that was yesterday. I switched from smoking weed to drinking my 40 can of Guinness. Uh, uh, no, I do not. So, let's think of it from a point of view here. No. Sterling's like, no, never, never. So the answer to that question is, do you smoke weed? And the answer you're gonna tell me if I'm a police officer is no. There's no way in heck you're gonna be honest with me, okay? Because at that point, instead of me being just a regular dude on the street, now I have a stake in the game, right? Right. I do not smoke weed, officer. Right? I have a stake in the game. You could get in potential legal trouble by telling an officer that you smoke weed. And that's not something that you want. You don't want to get yourself in trouble for something like that. So in reality, you're not going to respond with your true feelings about that particular question, depending on who is asking you the question, or if the question itself or the topic itself is very embarrassing or very sensitive, in which you do not want to actually reflect your true feelings towards. So if it's an embarrassing topic, a sensitive topic, you may not be as honest as say just a regular dude on the street who's asking, hey, I got, I don't care if you do or don't care if you don't. Do you do it or not? Okay, tell me yes or no. And it's completely anonymous. So hence where the idea of social acceptability or response bias comes into play. All right. I'm sure you guys have lots of stories to tell me. 100%. All right. All right. All right. Let's look at the last type of bias here. In my opinion, the last type of bias that probably is, in my estimation, social acceptability bias. That can happen for certain surveys and certain questions. Stuff here. Um, let's talk about the last type of bias here, and I'm going to put this up on the big screen. All right. So last type of bias here that we need to talk about probably is the most applicable type of bias in today's society, and that is referring to confirmation bias. Now, what is confirmation bias as a base definition? Now, this is not in the textbook here. I'm just going to point that out here. It's like kind of my lone little aside, but again, if we're talking about bias, then we certainly have to talk about confirmation bias. The confirmation bias is like surrounding yourself with like-minded individuals or content that promotes your point of view and affirms your beliefs. Okay? This in itself, this is pretty dangerous. Now you're probably saying, why is this dangerous? Well, I took the best example here, which is probably a Facebook feed, or maybe, as was pointed out here in my last class, a Google search stuff. Now, the reason is why confirmation bias is pretty dangerous is let's put it in a scenario here. Now, let's say you have particular beliefs, you have particular points of view that you support. Okay. Now, the problem with most people do today is that if you're on the internet, whether that be a TikTok, a YouTube, a Google, okay, all right, Instagram, whatever, Facebook, I don't really care. What is things that you see things on your feed that basically reflect the things that you like. So like on a Facebook feed, you may say, "Oh, well, I like this," and so of course you look at links regarding some topic that you really like, and of course on your Facebook feed, it's going to keep telling you certain websites or certain things that reflect those things that you like. In a sense, those things essentially manipulate you to put yourself into an echo chamber. I don't know if you've heard of the idea of an echo chamber. Probably you have, but or it's like a cult, right? The problem is with an echo chamber is that it's just what's wrong with Twitter, right? Twitter is extremely toxic, okay? That's why I barely go on Twitter, right? I say things on Twitter, but really only sports related stuff. But Twitter's really toxic because people want to be in an echo chamber. They always want to be told that they're right. Okay, the thing is that you have a point of view about a certain something. The problem is that if you're always told you're right over and over and over again, then you get this idea of confirmation bias, and then your opinion about that particular topic or thing becomes more and more extreme. And at the end of the day, that more extreme opinion, the more extreme that you are about that opinion, the more zealous that you are about that opinion, then the problem is that you will not be willing to listen to anything that counters that. There's no form of actual civil discourse or civil argument over that particular topic or thing. And it starts, and things get pretty nasty after that. Now, I'm more of the lines of saying, hey, I got to listen to both sides of an argument in order to determine the conclusion. So, that's very important here. But with confirmation bias, the more and more you're told you're always right, well, then that's a problem. That's a problem because you will certainly shut yourself out from another point of view that could counter that particular belief. It doesn't mean you're going to go with that, but it gets to be to the point where you lash out and you get angry and you get all this stuff that happens on Twitter all the time of all this other nonsense. So, now let me ask you guys a question here. All right, a fair one too. Um, have you guys been Have you guys been now? Everybody here, I think, has been a victim of confirmation bias. Do you feel that you've been a victim of confirmation bias at times? Do you feel that that's happened to you before? Yes or no? Do you feel that that's happened to you before? Do you feel that people are more extreme? Or have you felt like have you felt that way, or you felt that no, absolutely. You guys tell me, yes or no. You guys feel that that's happened to you? Because it happens all the time on social media. Yeah. You see it all the time. Not sure if it's happened to me, but I see it and hear it. Well, the thing is, that's the thing, is that you're never sure that sometimes you're not sure that it's happened to you. But let me ask you this question here, Sanla, and that is, have you felt really strongly about a topic in which you kind of raised your voice, whether it be online, or whether it be face to face with like a family member or something like that? I don't know, but or maybe a friend, it doesn't matter. So um but have you raised your voice because you're really super passionate about that particular topic? you know because I'm sure that a lot of people have, and you probably, the thing I would ask you is that if that's the case, yes, then how did you get to that point to be that zealous about that particular topic, or that fervent about that particular topic? How did it get to that point? Because that's what confirmation bias does. That's why it's dangerous in that respect. Because that's how I look at it. It's like, how did we get here? You don't know. Sometimes it just happens gradually. It just happens gradually, like little by little by little. Like, it doesn't happen all at once necessarily, where it's like you totally turn into like, oh, okay. So, but you turn, it's like, kind of chips away, and then suddenly, you get like super passionate about it. I don't know for you, Sanla, if that's happened to you before, but you know, um, that's that. I think people want to agree with them without question. I think that's true. And I think that's part of the echo chamber. That's part of the confirmation bias, is that you always want to be affirmed that you're correct. You always want to be told that you're right. Now, let's talk about it this way. People pretend to listen to other points of view. That's correct. I don't disagree with that. I think that pretending is probably. Now, I will say this, Stella, in relation to that comment, and that is, if there's one thing I do not like, if it's like my own personal pet peeve, if you want to know, one of my biggest personal pet peeves is when people are fake. When people pretend to listen to your point of view, but in actuality they're just tuning you out. Well, that just makes me upset, because I'm like, well, you're just wasting my time then. Then it's really like, okay, if you didn't want to listen to me, you could have just walked away. I could have been doing something more productive with my time. You're just wasting people's time, and you're wasting people's energy. So yeah, the fakeness can stay over there, because I don't want any part of that. I want to listen to people who are willing to listen to different points of view, and are willing to maybe not change their conclusion, but at least understand the other point of view that is presented to them, without getting too crazy over their particular point of view, in my opinion. I think a lot of times that can certainly happen. Yeah, debate or conversation is good. Having a good civil discourse, 100%, Eugene, is absolutely correct. I totally agree with that. Now, like I said, we all have our own personal biases, our own personal beliefs. And like I said, I'm not going to be here to tell you politics in here, okay? We're not talking politics in this class. But as long as we have an understanding, We may not agree with each other on certain topics or subjects, but at least we have the understanding of each other's points of view and can acknowledge them in some way. That to me is very important. I'll give you a good example about how I like to do it. Because admittingly, this is a really vicious cycle that you can fall under rather easily, as you all have pretty much admitted to me. So the way I like to do it here, let me give you the easiest example here that I like to do. So let's say I go to CNN. All right. Now, CNN is, as you know, is a left-leaning website. Okay, so it is a Democratic-leaning website. It is a Democratic-leaning channel. Okay, that is CNN in a nutshell. Okay, so this is going to be more of a progressive, left-leaning sort of deal. And you can read articles about this if you're talking about politics. You can read articles about this, like this article about President Biden. All right, so that is what it is. Now, that's from one point of view. That is from one point of view. Now, I could go to so what I do is I read an article from here. Then in order to get a proper perspective here, instead of just leaning in one direction, I'll also go to its counterpart here, which is the Drudge Report. Now, the Drudge Report here is a right-leaning website. It's a conservative-leaning website that has an amalgamation of a lot of articles that are more conservative in nature. Now, you could say, well, this is more a right-leaning website as opposed to CNN, and we'll have articles that basically will provide a counterpoint to, and they're kind of right-leaning sort of deal. And so basically at the end of the day, I'll read contending articles from both sides, and then I'll make a determination to kind of read between the lines and then make a conclusion based on what I read. And in that way, at least I understand from both points of view. Right? Yeah, I'm gonna allow that because that's pretty funny. Uh, uh, so if you again at the end of the day, what I would like you to do is understand from both points of view if you're gonna get out of the cycle of confirmation bias and make your own conclusions at the end of the day. I'm not here to tell you what the conclusions they should be. Always think for yourself and make those conclusions for yourself. Don't let other people tell you what those conclusions are. I want you to think for yourself and make conclusions for yourself. Make sure you get out of the vicious cycle that is confirmation bias. Try your best with that, and then make your own conclusions based off of that. That is what I would like you to do here. I went into a video call. My friend came in. I forgot the camera was pointed at my crotch, so he was like, "Dylan, yeah, that's that's kind of a thing. That's kind of a thing, Dylan. I don't know what to tell you there. You need to be careful about where where your camera's pointed there. The camera's pointed to my face, so it's fine. Neurotic, my friend. How you doing? Kind of sus. Kind of sus where you place that camera there, Dylan. Kind of sus, my man. I'm doing fantastic, my friend. Absolutely fantastic. Absolutely fantastic. We're talking about confirmation bias here. So hope you're doing well, my man. Hope you're doing well. All right. Very, very good. Very good. Okay, any questions about confirmation bias? Any questions about that? Still mathematics, but it's important to understand what bias means in terms of mathematics and in everyday setting. Technically, this should be added to the textbook because, in all honesty, I believe that even because statistics can lie to you, admittingly, if you fudge the numbers enough, then there is confirmation bias to try and showcase a narrative in one direction. But that's why you try and remain as unbiased as possible. That's why I like to remain neutral as much as possible, because I don't want to be like, hey, it has to be this way or it has to be that way. Most things, and I think you all can agree, probably fall within the gray area more than they fall, in the black or white sections. So there's certain things that everybody can agree with that are things that are right or wrong, but most things that we make arguments about, you know, probably like if you'd say 90-95% of things are going to fall in that gray area where you have a little bit of leeway. So, as I like to say though, please, please, please determine it for yourself. Please think for yourself. I would love for you guys to do that. That's very important to me. All right. Okay. Um, let's look at number 8. All right. So, number 8 here are what are types of experiments? Types of experiments here, we have a single blind and a double blind experiment. We did talk about this before when we talked about clinical trials. Um, clinical trials? Like this teacher, Loki. Thank you. um, what are the types of experiments? Now, single blind experiments basically is the researchers know who got the treatment and who did not. Double blind is that neither side knows who got what treatment or what. So double blind is the best because it removes the bias out of the experiment. So pretty soon. High key, low key, some key. All right. So we did talk about this last time, so I'm not going to expand upon this too much. We did talk about this last week. All right. Let's talk about these last two questions here, which are relevant for Chapter 1. So let's look at number 9 here. Number 9 says, What is a completely randomized design? So a completely randomized design is a randomly designed the experiment with a random control group and a random treatment group. So as we're testing out medicine here, you randomly select the people in the pool to be part of your control group, and you randomly select the number of people here who are going to be part of the people who got the actual medicine, and then you compare and see what results that you get based off of that. So all random, completely random for each side, and that's pretty much straight up here. A single blind and double blind. So a single blind study here, strolling is basically, again, the researcher knows who got what. So researchers know who got the placebo and know who got the medicine. Where a double blind is that neither side knows who got what. So that's the difference there. Is that the researchers don't know who got the medicine and the researchers don't know who got the placebo. So that's the difference between single blind studies and double blind studies. Okay. All right, let's take a good look here at number 10. All right, let's take a good look here at number 10. What is a matched pairs design? Now, this is something that we may see later on in the semester. We may see stuff regarding matched pairs design. So basically what that means is that is an experiment where one person from the control group is paired with one person from the treatment to compare and contrast with. So let me put it into perspective here. Let's say we were testing a drug here for diabetes. All right. Now, both patients that we could select for our clinical trial, our drug trial, they both have diabetes of some type. In this case, if we want to do a proper compare and contrast, maybe they have a similar type of diabetic condition. So like say they both are type 2 but diabetic. But along with that, besides having the same type of diabetes, maybe as well as that, they have a similar health profile or health history. Okay. And so those two people would be very ideal in order to pair up together. So that way we can see what would happen between a person that would get the treatment and the person who did not get the treatment. So a person who took the diabetic drug, what is the effect on them compared to the person who did not get the drug with again similar health profiles and again with the same type of condition. That way you can see was the medicine effective or not. All right, and then you can mark down your observations and results based off of that once you make that comparison. So it is very important that you go ahead and do that so you can clearly see, was the medicine effective, was it not effective, what are the side effects with people who have this particular health profile or this, what are the not side effect, what's let's compare it to the person who has the exact same health profile and condition, but did not get the medicine. So again, match pair design. Again, get those direct results. We can get that ball rolling. All right. In any case, that is the end of chapter 1. Any questions from chapter 1? Any other questions here from chapter 1? All right. Okay. All right. So that is the end of chapter 1. Those are the definition stuff here. Now, most of this stuff is like I said, all this whole chapter here was definition based. We'll go ahead and move forward. But now let's get into the more numerical based part of the program. Okay, so now we can talk about numbers, and I think that's just handy dandy and grand. All right, so let's do number stuff here in section 2.1. We're going to start chapter 2 here, and in chapter 2, we're going to talk about how to arrange data, how to organize data, in order to get it to a point where we can start drawing conclusions or getting other pieces of data from let's say our study. So, in order for us to do that here, how do we arrange data or organize data here? So the first thing that we'll talk about here is question number 1 here on the handout for 2.1 and 2.2. We're just going to be doing 2.1 here today, by the way, or part of it maybe. So let's look at question number 1 here. What is frequency and frequency distribution? How long is the class? We go until 7:15, Eugene. 7:15. Though I will say, the longer you look at the clock, the slower it'll go. I'm just saying. Don't worry though. We go for an hour and 15 minutes, all right? Okay, so let's look at frequency and frequency distribution. So what is frequency here? Frequency is how often something occurs in a category or classification. So let's say we're taking down our data and we're saying, okay, hey, how many times does this such and such thing occur in this category? We could say it occurs 3 times. Okay, that's the frequency in that particular category. All right. And the second one here is frequency distribution. All right. Now, frequency distribution is going to reflect that chart or table that we want to make up with all the categories and their respective frequencies. All right. So by far and away, this isn't too hard to do. It's pretty straightforward. But we're going to take a look at an example here, and we're going to see exactly how we can set up a frequency distribution. All right. Let's do it. Okay. All right. So what we're going to do here, what we're going to do here is let's go ahead and set this up with let's say we have a set of numbers here. Let's say these set of numbers here are going to be test scores. Okay, so let's say they're test scores of some variety. All right, so I'm gonna basically just come up with some random numbers for test scores, and we'll see what they're at. So 73, 62. Let's do 88, 80, 97, 54, 1, 8, 1, 89, 99. Here. 70. 99. Let's see here. 74 and 60. All right, so let's just come up with that. All right, so that's fine. All right, so I just randomly came up with these numbers here. Here they are. There it is. Okay. Now, let's take a gander here at how we can come up with a frequency distribution. All right. So, there are a couple of things I want to talk about here before we get to that point. The first thing that I want to talk about are a couple of pieces of terminology that you'll hear me say often here in this class. The first thing that I want to talk about here is the concept of a data item. So you'll hear me often say in a lot of different examples, not just for this chapter or section, but for other chapters and sections. So what's a data item here? A data item here is going to be, again, an individual piece of data. So like 73 is an individual piece of data or an individual score. Okay. And you'll also hear me say the term data set. So what is a data set? Well, a data set here is the group or collection of all data items. Okay. So you'll often hear me say, so all these numbers here put together, this is all a data set, and each one of the individual scores will be a data item. Okay, so it's not intended to be too hard, but it is what it is. Okay, now let's set this up here appropriately. Okay, so let's say we have a column here for scores. Say we have a column here for frequency. Okay. All right. So let me ask you guys a question here. How can we arrange the scores here in this instance? What's a good way to arrange the scores? Just from what we can see here on screen. Tell me some ways you could arrange the scores. Ascending, okay, that's a very good way, right? You could go from low to high. I agree with that. Okay. What's another way we can view test scores? What's another way we can arrange this data? Another way we can look at it. Like if you got your test back, right? Let's say you got your test back and you got a 99 on your test. What's another way you could call a 99? There's another way you would call your 99. I got a 99 on the test. What else does that mean? What do you guys think? So equivalent to A or B, right? By grade range, very good. 50, 59, 60, 69. Letter grades. So you could do A, B, C, D, F. 100% true, right? You was like, okay, look, you go with letter grades. Okay, you could also go with, again, grade ranges from 50s, 60s, 70s. Rounding. So what I mean is, like, how would you just organize them by categories? I guess is the best way to kind of ask the question here, David. Is like saying, okay, if I'm going to categorize them, how would I best categorize them? Again, ascending would be one. Letter grades would be another one. Again, you could do it by grade range. And actually, Horitz's suggestion is the one I'm going to use here. Is I'll go by a grade range here based on where the scores are located. So let's go with that. So we'll go with scores from 50 to 59. 60 to 69. And we'll keep going here. 70 to 79. 80 to 89. And then finally 90 to 99. So I'm gonna pick on those here. Okay. Just like so. So really just trying to get all these data items into some categories. Here's what we're kind of after. Now, I kind of like this. There's be a few reasons why I selected it to do this way, but we'll talk about that here probably next class. But in any case, let's talk about how many data items actually happen to be in each individual category or class. All right, so how many scores do we see here are in the 50s? Why don't you guys tell me, how many scores do you see here in the example are in the 50s? It's going to be our frequency here. Scores are in the 50s. Okay. 2. All right, very good. So we have 2 scores here between 50 and 59. So that's going to be our frequency for the 50s. All right, how many scores do we have between 60 and 69? How many scores in the 60s? How many scores between 60 and 69? Okay. Get 2 or 3. Let's take a look here. We have 62, 67, and we do have a 63 here on the end. Be careful about that. That'll be the 3 that we have there. All right, there we go. Perfect. Good. So far, so good. Perfect. Let's look at the 70s. How many scores do we have in the 70s according to our data set? Got 5. All right, let's count this here. 1, let's see, 1, 2, 3, 4, 5. Yes, okay, good. We have 5 scores here in the 70s. Excellent job, everybody. All right, perfect. All right, let's look at the scores in the 80s. Look at the scores in the 80s. How many scores are in the 80s? 4. Okay, good. The answer here is definitely 4. There we go. And let's take a look here at the last one. How many scores in the data set are in the 90s? All right, so the answer here is 2. We have 2 scores in the 90s. Very nice. And now, effectively what we've done here is we've now effectively made our frequency distribution right here on screen. There you go. That's it. We've been able to look through every data item in the data set, and then we're able to figure out where they fit into each individual category. Okay, that wasn't too bad. That was pretty straightforward. Pretty nice. Good stuff. Okay, any questions about that before we move forward? Hopefully that was pretty simple. Okay, any questions, guys? Any questions before I move on? Again, if you don't have any questions, please type no in the chat. Okay. All right, so I'll move forward here with the next question. I'm going to keep this up as a half and half, so All right, let's take a look at the second question here. So the second question says, how do we calculate relative frequency? So not only are we talking about frequency distribution, we'll also talk about relative frequency as well. So how do we calculate relative frequency? Well, to calculate relative frequency, we're going to take the frequency in the category or class. Again, this is also called a class. Categories are called classes, just another name for it. Divided by the sum of the frequencies. Now, let's take a look at our frequency distribution here over to the right, and we'll see what we're talking about here. Now, if we took all these frequencies here and added them up together, all right, so 2 plus 3 plus 5 plus 4 plus 2, if we add them up together here, we get the sum of the frequencies here is going to be 16. All right, if we added all those numbers together. Now, 16 here is a very important number. Why is 16 an important number? Well, 16 is an important number because 16, I'll make this bigger for a second. 16 is the amount of data items in the data set, right? We have 16 test scores here that we've put into our table here. So again, if we did this frequency distribution correctly, that should equal the amount of data items in the data set, which it does indeed. There are 16 data items in the data set for this problem. Okay, now having said that, if we're going to do relative frequency, all right, we're going to take the frequency in that category, divide it by, again, the sum of the frequencies. So let's take a good look here at each one. So we'll make a new column here. Okay, so for example here, for the first one, we have 2. So we're going to take 2 over 16. So 2 divided by 16 here. Now, what I would like you guys to do is tell me what the decimal equivalent is going to be here, because I do actually want the decimal here in this case. So could you tell me here, what's the decimal here for 2 divided by 16? I will actually write out that decimal. So if you need to use a calculator for it, go ahead. That's what it's useful for here. I don't care if you use calculators or not here. All right, 0.125. All right, so focus says 0.125. All right. All right, so 2 divided by 16 here will be 0.125. Let's do the next one here. How about 3 divided by 16? About 3 over 16. What's that? 3 divided by 16? What's that as a decimal? Let me know what this decimal is. Come on, guys. Give me the full decimal here. Full decimal. I don't want you to round here in this case. 0.3125. 3 out of 16? I don't think so. Okay, let me yeah, so let me state this here really quick. Let me go back for a second. Let me talk about rounding here. Rounding in this class, the way we're going to do rounding here in this class is that we're going to round to 4 decimal places. Now, most problems here in the textbook and most problems in statistics are going to go to 4 decimal places. However, I will say this, my math lab may require you to do a different amount of decimal places. So please make sure to read each homework problem carefully to determine how many decimal places the problem wants. But for our standard MO, we're going to go to 4 decimal places. All right? So 4 decimal places here is going to be the way to be. All right? So please make note of that. That's how I'm going to do a lot of these examples, is do 4 decimal places for that. Okay. So 0.1875. Okay, good. All right. Good, good. Let's do the next one here, which is 5 over 16. What's 5 divided by 16 here? All right, that is 3.3125. Okay, that I'm going to agree with 100%. All right, very good, very good. This last one here we don't need to do because it's already 2 over 16, so we already know that from the first one. 4 over 16. So 4 divided by 16. 0.25. Okay, pretty easy. Okay. Now you're probably wondering why I asked you to do decimals here for each one of these relative frequencies. Let's talk about why I've specifically asked you for each one of these decimals here. It's because when it comes to relative frequency, each one of these decimals here, as you know, will reflect a percentage. Okay, so for example here, this we could say for a certainty that we could say that 12.5% of the data items in the data set fall within are within the 50 score range, so between 50 and 59. Okay, so we could say 12.5% fall within that particular score range. All right, so again, each one of these reflects a percentage, and if you do this correctly here, the relative frequency, if you add up each one of these decimals here, what you should get is exactly 1, or approximately 1, because we do round here to 4 decimal places. So if you get a weird decimal and you have to round up a bit, you may get something in and around 1. So you either get exactly 1 or get something very approximately very close to being 1. If you get those two, if you get that there, then you've done the relative frequency here. Again, 1 representing 100%. Okay, so that in a nutshell is why we do relative frequency to also determine, hey, where are the majority of the data items located, or what percentage are they located in as well. So certainly data that you can certainly glean by setting up the relative frequency. In some cases, especially for larger data sets, maybe not this because 16 items is fairly small, data items is fairly small, but if you had like thousands of data items and you wanted to summarize that, maybe relative frequency would be a lot easier to look at in that regard in terms of percentages. Okay. All right. All right, so just to let you know, this was the answer here for number, let me go here for a second. There we go. This here was the answer to number 3 as well. How do we make a relative frequency distribution? Well, we just set it up as this column you see here. This would be the answer to number 3 right here, about how we can make a relative frequency distribution. Okay. Are there any questions about relative frequency distribution? None from you. Okay. So basically, this is where we're going to stop here for today. This is where we're going to stop here for today. Now, I just want to talk about what we're going to be doing here next time. Next time here, ladies and gentlemen, is we're going to take this same exact example. So make sure you have the same exact example here. We're going to take the same exact example, and we're going to be doing a little bit more with this example here, because we're going to be using the frequency distribution. We're going to be using the data items in the data set to actually arrange this data in a few more ways and actually look at it from a slightly different perspective in a few different ways. So what I'm going to do here is, this is the example specifically for this class. So what I'm going to do here right now is I'm going to save this. All right, and I'll save this as the other one here. So Math 102 example number 2. So Math 102 example number 2. So this will be your specific example that we're going to start from for next time, okay? Because we're going to do a lot more with this here in the subsequent questions here from the handout in chapter 2. But I'm sure you guys are at least a little bit comfortable about how we go ahead and arrange some of this data here just to start with. So we're at a pretty good juncture here so far. It fell fast? Oh, thank you. Thank you, folks. I appreciate that. I'm glad time goes by really quick. I hope it's supposed to. Try to make this as easy as possible. I promise you. But this is where I'm going to end off here for today. All right. Okay, everybody. I want to thank all of you for coming on out here to the stream today. If you've been up since 4:30 a.m., I hope that this is a wonderful end of your night, at the very least, Eugene. I hope everybody enjoyed themselves here today. I always look forward to seeing you all here, and I'll look forward to seeing you all here for next time. Bill, I don't know if you've connected to my Discord or not. Just let me know. I'm gonna put the Discord link here, and then you can connect to my Discord if you haven't done so already. That is an invite to my Discord. So, go ahead and put. Where are you? There you are. Okay. So, yeah, I'll talk to you over Discord here after class, Bill. And then we can get things sorted out. So that way, Stella, thank you for the follow. Appreciate you. We can get things sorted out so that way we can get my math lab and all that stuff set up and ready to go. Okay? All right, so I'll be waiting on here on Discord. In the meantime, again, click on that link, and if you have Discord available, click on that link, Bill. You should be if you haven't already been invited, this is a free link, and then we can talk about getting you set up. Okay. All right. So again, this is free for you. If you need to talk to me at certain points, you know, it's easier through Discord rather than email, so I can view your computer in real time. Okay. Thank you very much, everybody, once again. I love you all. All of you are absolutely fantastic people. All right, Bill, I'll talk to you in just a little bit. All right, have yourself a wonderful night, everybody. All right, take care of yourselves. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane, everyone. Have yourself a great one, and we'll see you on Thursday, same time, same place. All right, everybody, have a great one. We'll see you later. All right. Bye. Bye, guys. See ya.